I'm just gonna start now because I don't really know if OBS is broken or if it's just me. But what we're gonna be doing today is going back to the code here where we made the original JS file with all of this. And what we're going to be doing is compressing all this and learning some basic compression techniques that are on the GitHub, just things that you can use universally to shorten your code, which is the, I guess, main objective of Dwitter. And we're going to take what we had from last lesson, and if you haven't watched it already, it's uploaded on the channel. We're going to take the code from last lesson and apply some of these techniques to make it as short as we possibly can. And we're going to put this in a new file called stars compressed. Okay, so I guess the first thing we should be doing is taking all of this code and moving it into here. And we're going to start with this and kind of take pieces out of what we were making before and see how we can construct them here. So, well, obviously the first thing we're going to need to do is define a for loop. And the for loop, it can work two ways. Essentially, you can do stuff forward, so like I equals 0 and then increment it, or you can do it backwards. And most of the time, backwards is the way to go, because if I show you here, I equals, for example, 2e3, and I'm actually going to take the spaces out so it's easier to see how this is compressed. And if I go I minus minus and put my code in here, whatever the code's going to be, I minus minus is going to run this, and it's going to run it until it's until it's 0, and then it'll loop over the thing again. And that's significantly shorter than for I equals 0, I less than 2e3, I plus plus, and then putting your code in here. It's shorter by far. And you can put other code in here, like you can put fill styles and stuff. So I would have to put extra code for all the fill styles. You can see it's shorter by a margin. So this is why we technically do, usually do for loops in reverse. But in this case, we actually are using I equals 0 for something. So in order to shorten it while still keeping this I equals 0 thing, to make the black background, we're gonna still need it to go forwards. So that's one of the limitations in how we're gonna get things compressed. So let's just put the basic code down, I less than, and we're gonna replace all the constants, like just numbers right now, with letter C, and we'll go back to them, sorry, we'll go back to them later and see what we can make of them to make our code short. Okay, so I guess the first thing we should talk about is these brackets. They're unnecessary in JavaScript, and they're more for formatting, for code style, but in our case, we really need everything to be as short as possible. So for now, we're going to take these out and simply work on this one line. So what we want to do is take our code from before, x.fillRect and x.fillStyle, the ones that we implemented here, and we want to essentially compress them. So what I'm going to be doing first off is just taking this. It's going to autocorrect because VS Code is doing it bad. But well, you see we need x, y, width, and height, which we have over here. This is what we've defined them in the previous lesson, so I'm just going to put them in here. And you can see it's already getting pretty long. That's mainly because of the white space, but that's a simple fix. And then both of these are going to be the same thing, right? Alright, so this is really long, and we're not even done yet because we need to put in x.fillStyle. So in order to make a new line on this one line, what we use are commas, and then we can use other functions. So I'm just going to take this from previous lesson and just put it in there. Okay, so this is what we have so far, and this is a little intimidating at first. How are we going to shorten this? And I guess we can start by looking a little bit into the wiki for Dwitter. It's a great resource. I'll put it in the description when I release the actual video. But what we have here are some golfing tricks. Code golf is essentially getting code as short as possible, which is the aim in Dwitter, getting it under the 140 character limit. So I guess the most general thing we should start off with is just canvas, because usually canvas is going to be helpful. And you can see text instead of rex, all of this. And we kind of just want to look through it, see what it has. Canvas isn't actually going to be all too helpful. What would in future tutorials is this statement right here, c.width, and this bitwise operator, bitwise assignment, n equals 600. We're not clearing the canvas, but as you can see here, this is a way to clear the canvas, and it's I think the shortest way uh, on Twitter for this purpose specifically, like purposes regarding for loops and all that. But we're not clearing our canvas because the black background is essentially doing that for us every single frame. So we can move on to Twitter specific ones. There's not all too much here that you're going to be using pretty much ever. Some shorter ways to call functions, all of that. There's a lot more in general JavaScript. It's just going to be used a lot more because it's general. You can see instead of the brackets, like I told you before, you can use commas to do multiple things inside a for loop or an if statement or any of that, and it'll save, I think that's 2 bytes, 2 characters. This is going to be important. This is something we're going to use right now, and I'll show you how to use it in the code. You see, we have our code here, and this is short. This is pretty short, right? But we can save an extra byte if we actually put the code, one thing of our one thing that's going to be running in the for loop into this. It's pretty much the iteration part of the for loop, and I can show you that over here. So we have our x.fillRect, which is all of this up until x.fillStyle, and we have the comma over here. So what we can do is we can actually take that from outside here, and we can store it inside here. And you might ask, well, there's an issue with that. We're not iterating anything, and that can be fixed because we reference I multiple times, so we can just stick plus plus or minus minus, so iterators inside it. So I'm gonna actually take some of this out for purposes of explaining, because it's kind of hard to see all of this if you don't see it properly. And that's should be it, I think. Ignore my bad formatting for now. Uh, yeah, that should be somewhat correct. Okay, so this is a little more readable, and we'll remove the white space after, but this is it for now. And we can simply just remove one of these I equals zeros with something else. So you see all this I equals zero, it takes quite up a lot of space. And really what we could do is just remove it here, right? And instead of checking for I equals zero, we could check for I equals or not equals zero. And in JavaScript, this is the same thing as just doing I, because uh, if I is zero, it counts as false. We also need to reverse this because we reverse the operator. And we can do that for each one. And for the width and height, these are actually the same thing. So what we can do is just simply create a variable of sorts. So for example, s for size. So s equals and then everything in here. And instead of redefining all of that, we can just put another s since it's technically the same exact thing. So this is, if you repeat code, it's going to be going to show up in the height parameter as well. So width and height, same thing, just assign a variable. Let's go back to the wiki and look through a little bit more of this. A lot of this you're not going to need in this one, but you may need in others, so it's a good resource to have. Okay, so one that's really important is mathematical JavaScript tricks because they're going to save a lot of space. And as you can see right here, um, thanks to JavaScript type coercion, if you need a zero, you can often get away with false instead. So instead of doing something like a conditional, if a conditional, then do this, else zero, what we can do is if a conditional and this. Because if the conditional isn't true, then 0 and 2 times I will count as 0, and it'll just return 0. But if it is true, it'll return this. So if we go back into VS Code, we can take out these I conditional else 0, and we can simply replace that with and. Um, and we can do that for most of these, right? Because this is also false equals 0. This one is going to be not something you can handle or change because it's not uh, if this else 0, it's if this else 2000, and that's not going to uh, show up if you do the and. trick over here. Um, One thing I was talking about earlier, but kind of went off on a tangent and didn't address, is how are we going to iterate over this for loop? Because right now there's nothing iterating. It's just going to stay at 0 and continue this running this forever, and it's going to time out. The dweet's going to time out. There's a lot of places we can put this, but I'm going to put this simply in the size variable, the width and height, so that after each run of this for loop, it's going to increase I by 1. And with that, we've saved quite a few bytes. Um, we need to address specifically the constants and how we're going to use them and how we're going to make sure their usage is as minimal as possible. But I guess the first thing we need to do is kind of experiment and see what looks good. Uh, Part of that is knowing what each constant does, and I've addressed that in the previous video, but you see it's not going to run because C isn't defined. Um, we can kind of just set C to a constant here, just to test, really. Capital C in Dwitter is cosine, so I'm actually going to take that out for now and replace it with lowercase c. Uh, we're not really using cosine, and one thing you can do is assign values to functions, but for now it's a lot easier to understand if we just take out all of those capital C's and just use a lowercase one. So let's set C to like 200. This is a bit confusing. And the reason is if you haven't looked at if you like write all this code in something like VS Code and you kind of understand how it works, you don't understand completely what you're doing, and this is what shows up, you're going to be very baffled and you might um, give up a bit early. But we can fix this because what we do know is what each constant represents. We know that if we go back into VS Code, we've shown what each one represents. This constant represents x separated, so how far away each star is going to be separated. And what we can do is just assign each one of these variables. So instead of just assigning them all the same, for now we can just experiment with what each does. We know this first constant over here decides how many stars there are going to be because the index is looping over each star, and this uh, comparison decides when it's going to stop the for loop and stop drawing stars. So we're just going to set this to something for now, let's say 100 stars. I'm going to uh, put the constant back so we can see what it does. We can see there's a lot less of them. If we turn it to 10, there's going to be a lot less again. And if we turn it to something like 1,000, there's going to be a lot more. And it's also going to run slower. So let's keep that as at 100 for now. We talked about this first constant, the one I times c in the x coordinate, represents how far each one is going to be from each other uh, by determined by offset as I. So what we don't want happening is we don't want the stars separated and the time. Uh, Here, if I go back into VS Code, we don't want them to be the time that each one takes to go from left to right, and we don't want them to have the same star separated constant, because that'll make all of them go at the same time. What we do want is to change this. So I'm just going to experiment with like 10. You're going to see the difference is now easily seeable, that uh, they're separated now. Um, let's go to t times c. So this is how fast they're going to be going. And one thing I just said wrong was that if C and C are the same over here, it's going to, all the stars are going to be not separated. And that's just not true. I was kind of out of my head for a second. It's mainly because this mod operator over here, modulo. So it's going to run all of these and it's going to stop it at 200, and that's not enough room because we're just incrementing all of them by 200. So they're all just going to happen at the same rate because 200% 200 is just the same thing. So you can kind of think of this as an algebra equation where if I take I times 200, or yeah, I times 200 plus t times 200 mod 200. What's going to happen is I times 200 mod 200 just, it doesn't equal anything. It's going to equal 0 because any multiple of 200 mod 200 is 0. So really it's just going to cancel these out, and it's going to be t times 200. So the I won't matter, the offset for I won't matter, and they'll all just be moving at uh, the time times 200. So that's why they're all in the same place, not because I times c equals t times c, or not because the constants are the same for stars separated and left to right. But one thing we do want, after I go over that, um, we do want it so that these starts don't end right here. This is like taking up no space on the screen, and we need it to take up all the way from the left to the right. So we actually know what this should be set to because we know the size of the screen is 1920 in the x direction. So if I set the constant here to 1920, you'll see it's going all across the screen and it's looping back. And that's easily visible now. This is the effect we want. And this looks okay for the x-axis. I'm not saying anything about the y-axis yet, but this looks fine for the x-axis. One thing we do want is it to be separated more on the y-axis. So if we go back to VS Code, we had a value that determined how stars were separated, and this constant determines how much they're going to be separated. So we can find this constant in our code. It's right over here. And we can set it to something that's more than 200. We can set it to 400. This doesn't take up the whole screen. We can set it to 600. That takes up the screen. And this is looking pretty good for now. One thing I don't like is how far they're separated on the x-axis. So what I might do is just remove this, make it to like 20, maybe 2, not 2, 20. And that looks fine, I guess. Maybe a bit lower. One thing I found interesting was what this is doing. I times t times c. It's a different pattern. It's not important. Okay. think one thing there isn't enough of is stars right here because I kind of want them condensed like this, but you can see they're not taking up the whole screen, and that's mainly an issue of not having enough of them. So I'm gonna set it to something a bit bigger. 2000s, that's a lot more taking up the screen. Maybe I'll set it to 2e3, which is just shorter. It's also 2000. And just like remove this. Maybe set this to 100. I don't know. It's really experimenting, seeing what works. Um, maybe. It's not taking up the whole screen again, so I'm just gonna 2e3. That looks a lot nicer, in my opinion. So it's really just messing around with the constants. And this is pretty much the dweet. So what we're going to do is we're actually going to assign C to something that's very close to all of these values. So you can see 2e3 up here and 1920 are pretty close. And also 2e3 is being used down here and is also pretty much being used down here. So I think a constant being 2000 would work well. And what we can do is just take out all of these examples where the value is close to this constant, and now it looks pretty much the same, but we've shortened the code a lot. And there's some parts of this that aren't going to be able to be shortened, like 100 and 540, because if we set these to C, it'll change our code drastically. Same thing with this. This actually broke because I took out the 100. You can see it changes. So we kind of just want those where they were. And this is pretty much our dweet. If we take out all the white space now, just removing all this. Okay, it's a bit tedious. I could probably get something to remove it for me immediately. If that's a tool you guys want to make, that would be cool. But I'm just going to manually do it. Okay. Okay, so that's pretty much it. It's 106 bytes, which is probably or a bit more than my previous one, but I can check. Oh, actually, it's a bit less. Probably because I included some fancy stuff over here. But if I keep the fancy stuff, it's still a bit less actually. So I did a better job of compressing here, which goes to show you can always compress it more. So I'm going to end the stream here. I might do